Isn't it weird how the universe randomly chose some things to be particles and others to be waves? Well, it didn't. According to French physicist Louis de Broglie, everything made of matter, including me and you, can actually exhibit wave-like properties. Matter waves, a phenomenon called wave-particle duality. If that's the case, then why does everything around me still look like matter? It's all got to do with size. Let's look at this 1 kilogram ball moving at 5 meters per second and this formula, which says that the de Broglie wavelength of a matter wave is Planck's constant divided by its momentum. Plugging in the values, we get that the ball has a wavelength of 1.3 times 10 to the power minus 34 meters. That's really tiny. And that's the point. On our scales, de Broglie wavelengths are so tiny that we can't even notice the wave nature around us. So then, why does this topic even matter? For that, we need to zoom in. Meet the electron. At these scales, the de Broglie wavelength of matter waves becomes significant enough to have real effects, and that's what de Broglie needs you to understand. He doesn't want you to see an electron like this anymore, but rather like this. Okay, it obviously can't just exist like that. But then how would a wave even fit into electron orbits? Well, we know all waves have a wavelength, and we can say that the radius of the electron's orbit is r. Doesn't it then make sense to say that the circumference of this orbit, 2 pi r, must be a multiple of the wavelength for the wave to fit? This simple assumption actually explains a lot. It tells us that electrons must have discrete energy levels, since these energy levels must hold specific electron wavelengths. It is then these energy levels that keep an atom stable, something that classical physics was actually never able to explain. Thus, matter waves became a key scientific breakthrough that showed us that classical physics was still inadequate and that we needed a new theory to explain matter, what we now know as quantum mechanics. That's pretty cool for an effect that we don't even notice in everyday life, right?